All right, so again, good evening. I'm Bryan. If you saw my talk on the schedule or saw my name on the schedule and came anyway, I appreciate that very much. So anyway, I'm here to talk to you about vulnerability management, and there's quite a bit to get into, so we'll just jump into it. I want to say a quick word of thanks to BSides for inviting me to speak, and to my mentor, Megan, up here, for mentoring me. And hopefully we've got something special for you, and I hope that everybody can take something from this talk back home and use it in your organization. All right, so who am I? Bryan, security engineer at North State Technology Solutions. I have been in IT about 18 years and security for about 10 of those years. Back then, I worked for a private investigator doing some digital forensics, and that's what really got me hot and heavy into the security side of things. So now I do risk management and compliance, consulting, and of course, vulnerability management. So what is vulnerability management? Vulnerability management is defined as the cyclical process of identifying, classifying, remediating, and/or mitigating vulnerabilities. And a vulnerability in this sense, I'm sure y'all know, a weakness in an information system security design, implementation, procedures that can be exploited to gain unauthorized access to information or an information system. So why is vulnerability management important? Because the Center for Internet Security says so. It's not a bad reason. The CIS maintains a document called the Top 20 Critical Security Controls. And number 3, formerly number 4, but it's so important they moved it up to number 3, continuous vulnerability assessment and remediation. The goal of which is to continuously acquire, assess, and take action on new information in order to identify vulnerabilities, remediate, and minimize the window of opportunity for attackers. It's also important because around us we have a constant stream of threat intelligence. This comes to us from pretty much everywhere, from vendors like Microsoft and Cisco, security researchers like Bruce Schneier and Bryan, lots of other sources that we'll get to in a minute. And failing to keep pace with this just allows for easier exploitation. So example here, you have a vulnerability that's published and not responsibly published. So at that time, the information becomes available to everybody. It's available to the bad guys to weaponize and exploit, to the vendors so that they can develop and deploy patches, and to us, or I guess us, the good guys, to remediate and apply those patches and other defensive measures. So this isn't so much a how-to on vulnerability management as it is about my experience implementing this at a client. So this client back in Charlotte, North Carolina, that we have, and this client has 25,000 devices, and these are workstation and servers and point of sale. IoT is in there, and they're running Cisco and Windows and AIX, ESXi on there, and countless applications. So when we started this program with them, they had pretty much nothing. And what they had was always reactionary. So here's our scenario. There's an existing vulnerability discovered. So, I mean, what do you think happened? From experience, you know, what's happened in your organizations? This was ours. All the time, every time. So what would happen is everybody's hair was on fire, and we had to run this thing down until we figured out what we were going to do about it, if we were going to remediate it, if it needed to be remediated, and how to address it from there. So here's our next scenario. Here's a possibly applicable vulnerability. We might have this, it might be out here, it might be something we need to look at. It's on Windows, we know we got Windows, that's about it. So what happened? This. Every single time. Again, everybody's all crazy, everybody's hair is on fire, we're running around trying to figure out how to address this vulnerability. And this process, it was ultimately effective. We eventually got patches applied, eventually got updates done, but it was incredibly inefficient and just exhausting to everybody who had to facilitate it, namely me. So from my experience here, we have 3 primary components of vulnerability management. We have number 1, vulnerability discovery, so finding out the information that's out there. Secondly, we have vulnerability notification, taking the information we got from our sources and relaying it to whoever can remediate those vulnerabilities. And finally, remediation verification, so taking what they've said they've done and just verifying that it's complete. All right, so the first goal that we wanted to accomplish here was to improve our vulnerability discovery, our awareness of what was out there. So our first step here, we deployed a vulnerability scanner. It happened to be Rapid7 Expos. And the first thing we did was run a discovery scan. Now this client runs a /8 IP address. So in case you're ridiculously good at math or just happen to know this, that's almost 17 million IP addresses. And this took weeks and weeks to complete, but it was minimally invasive, didn't crash anything, thank God. And it gathered basic information. Now, every address, Nexpose gave us an IP address. Every asset, we got an IP address. Now, if it could be fingerprinted, then we would get an operating system and sometimes a host name as well. So that would give us the basic building blocks that we needed to scan further. And to do that, we would do credential scans. So we had an administrative service account that we would plug into Nexpose, and then it would scan those devices with the service account. Now, if the credentials were valid, it would bring back a lot more information, and since most of what we were using was Windows, that was very valuable information for figuring out what kind of software we had out there. So the next aspect for us improving our vulnerability discovery was a daily or weekly review, depending on the source, of information. So to do this, we had lots of sources. First of all, the National Vulnerability Database, the NVD. And this is a multi-format, downloadable, searchable database that lets you look and see everything that's out there this week. We could compare it against last week's and see what was new. Or it was especially fun the first time we looked at it and had to sort through 25 years of vulnerabilities and figure out what we might need to address. Secondly, the United States Computer Emergency Response Team, or USCERT, and they provide notification services. They have a weekly security bulletin for us to look at. Next up, vendor-specific alerts. So here's your Patch Tuesday and your regular updates from Cisco and VMware and Oracle and whatever other vendors that you're using. So the next source, security research and aggregation sources. So these include ThreatPost, CSO Online, and CyberWire. Also, we had penetration tests done as part of compliance process. So after going through this for a little bit, we learned to incorporate the findings from the penetration test as well. It's a very valuable source of information. And finally, social media. So like Bryan Krebs, Katie Masuris, Security Week, Megan Wu has a Twitter account, I guess. And then main Twitter accounts, they're constantly updated. So if you're looking for the latest and greatest vulnerability information, Twitter's where you go. So thanks to these sources, we've identified some vulnerabilities that we might need to address. So what now? The next aspect we had to consider was resource allocation. How do we prioritize these vulnerabilities in a way that's specific to our organization? So first, we looked at how vulnerabilities are scored by the industry, the Common Vulnerability Scoring System, or CVSS. And this is an open framework for communicating the characteristics and severity of vulnerabilities. And the CVSS uses 3 primary metrics: base, the intrinsic qualities of the vulnerability; temporal, aspects specific to an organization's, temporal aspects that may change over time; and finally, environmental, aspects specific to the organization's environment. So, and that uses a 10-point scale, as we can see here: low, medium, high, and critical. Now, these environmental factors that are built in the CVSS to help organizations try and rate these based on what they're using. So they use these dynamic components, and here's what they look like, right? And so we had a problem with this because it's just too subjective. And depending on who was reviewing what vulnerability, it was just a mess because you'd have different people coming up with different results. And look, it's a lot like this. This is what it felt like trying to figure out those critical components. Math, am I right? So we devised an alternate and simplified calculation scheme, the adjusted scoring system. So my acronym needs some work. I've been looking at it for a while now. So the purpose behind this system is to take into account the industry scoring, the CVSS, and combine lots of institutional specific factors. So there were 3 potential factors here with a maximum score of 10. The CVSS has a maximum score of 10. So we would add those together, and we would average those to get us a new enterprise-specific score to help us prioritize. So the first and largest factor we looked at was external accessibility. If any asset with this vulnerability was accessible from outside the organization, 4 points. If there were no assets that were vulnerable, it got 0. So the next factor we had was data sensitivity. In our organization, we had PCI data, of course, because we're a retail. This client also operated a pharmacy, so we had personal healthcare information to consider as well, and personally identifiable information. So those rated like this, and they are mutually exclusive. So if you had a system that had all the data types in it, then they wouldn't get 6 points from this aspect. They would just get the highest one. And the final factor was prevalence. And after playing around with it a little bit for our organization, this is what we came out for the sweet spot of where we thought prevalence would make the most sense here. If you're going to take this and try it elsewhere, you want to adjust these numbers based on the size of an organization. So by implementing the adjusted scoring system, we go from this down to this. So it's much simpler, right? So let's look at a practical example. I have using Cisco ICE in our organization, and the supplicant for that is AnyConnect. So we had this on just about every single Windows device out there. So quite a few devices. So it was rated a high severity, a 7.8. So we had to look at it and figure out, okay, we know this is a problem, how do we address it? So we took into account our different factors, internal only, within PCI scope, way more than 50 devices. So we did our math down here and came out with an adjusted score of 6.9. Still important, still needs to be addressed, just not right now. And this chart by the PCI DSS shows us this as well. So it's the same scale we talked about a minute ago. But for low, remediation is not required. So we had a lot of those that it just booted it right out of the park. Nothing to worry about there. For medium, it has to be addressed within 90 days. And so in the previous example, it knocked it down from we have to fix it in 30 days to now we have to fix it within 90 days. And that made it a little bit simpler, and we could prioritize anything above that was more important according to our system. So we scored the vulnerabilities, and we prioritized them for our organization. And then, throwback movie reference for you. So we get to the second component, vulnerability notification. Taking all this information and relaying it to the persons responsible for remediation. So this client had about half a dozen administrative teams to address these vulnerabilities on different level. For example, we may have a Windows server that's running Oracle. So we had the Windows team that patched Windows and the database team that patched Oracle. So we'd have to have those teams working together to remediate that, and that's just one example. There was several vulnerabilities that passed through every single team, just because of the nature of the vulnerability. So we would limit the number of vulnerabilities to 10 per team per month. We tried giving them all the vulnerabilities, but some of them had hundreds. They didn't take that too well. Yeah. So to do this, we would start with our Nexpose report, top 25 remediations with details. Very important, gave us a good jumping off point. And based on that, we would create 2 documents. The first one, we give them a spreadsheet overview so they could see at a glance, here's your 10, here's what you need to look at, and then give them all the information about our external factors, the CVEs, et cetera. And then we do a second one, a detailed document that would have that information plus any links that they might need to remediate this. And there were quite a few. It took some practice to get this going the right direction, but if we didn't do this, they would bug the snot out of us trying to figure out how to get us to tell them how to do their jobs, which is fun, of course. So we had the reports assembled, and we met with the teams. And so we had 2 meetings per team per month. And in these meetings, we had the team, of course. We had the security team, of course, and we tried to involve their management as much as possible. They needed some encouragement, let's say. Let's put it that way. So the initial meeting, the documents are presented to them, and we tried this in email at first, but we found that they would either ignore the email or would kind of give us half answers. So it was important for us to get out in front of these teams and give them the opportunity to respond, to look us in the eye and understand that this is important. It's something you need to look at and do something with it. So we'd have the first meeting, and then they'd come back for a second meeting, and they'd have our documents that were marked up and annotated with what they had done or were doing or what they had planned to do. So in these documents that we got back from them, we saw there were 4 responses. The first response, not applicable. Don't have it, not using that component, no problem. Secondly, false positive can be disregarded. Also, throw it right out, no problem. Next, it can be remediated. And here's where we come back to our timeline for remediation. Within 30 days for critical or high, or within 90 days for medium. That's great. That's the best case scenario. Or finally, it cannot be remediated in the predetermined time frame or at all. So we had a problem on our hands. So when we got the response from the team that they were unable to remediate it on time or at all, then we would generate a risk acceptance plan. So why do we need a risk acceptance plan? It's very simple. Because at first, we would try to just slough it off. Just kind of shrug our shoulders. Oh, it's not that big a deal. But we came to realize that these things have to be run by and approved by senior management. Because it's not up to the security team to accept risk. It's not up to the security team to accept risk. I can't say that loudly or frequently enough. But instead, it's the job of the security team to come in to inform and advise. And what constitutes senior management? So we thought about doing this at different levels at first. So having just the IS manager sign off on some of them based on severity, or the VP of IS, or the CISO based on what it was. We ended up having everybody go through the VP of IS. That just seemed to make the most sense for us. But senior management for your organization, a good rule of thumb is whoever's most likely to get fired if it goes sideways. That's a pretty good rule of thumb to decide who needs to sign off on it. So after we would put together, so what goes into a risk acceptance plan? So we would lay out our documentation. So we would give a detailed description, everything that management needed to know about the vulnerability to make an informed decision, including the scope, so how many devices were affected, the platforms, so what type of devices were affected. Are we talking about our point of sale here? Are we talking about our servers? Are we just talking about workstations? It's important to get this information across. And also in here, you want to lay out your worst case scenario, so that since they're signing off on it, you want them to have a good understanding of what they're signing off on and what the full implications of it could be. So you list your worst case scenario, you go through all the bad, and then you can come in and list the good. And here's where our vulnerabilities, some of them just weren't that big a deal because we had mitigating controls around them. And then, so because of these mitigating controls, it didn't really matter. So in our mitigating controls included your IDS, IPS, so your Cisco Firepower, your SecureWorks, Firewall, Cisco ASA, PAs, Palo Altos, your antivirus, your network segmentation. We had some where the device that was vulnerable completely segmented from everything else. What kind of risk is that? Almost zero. Application whitelisting. I'm telling you, that's the way to go. If you haven't heard of application whitelisting, what are you doing at this conference? If you have heard and you should look into it. If you've looked into it and implemented it, good for you, gold star. You are on the road to success. And include in here anything that might mitigate the risk of the vulnerability. So now we get to our third component, remediation verification. Ensuring that remediation is complete, because teams will tell you that it is when it's really not. So we discover vulnerability has been remediated, and the remediation has been reported. All right, so that's what we'd hope for from them. In this case, it's up to the security team to go out and collect evidence. So what constitutes evidence? Well, if you found out about it through your vulnerability scanner, it's pretty simple. You just rerun the scan on the devices. If it shows clean, you're in good shape. Also, configuration patch level screenshots for vulnerabilities that were discovered outside of Nexpose. Those are a little tougher. Also, vendor reports. So your Microsoft Baseline Security Analyzer, MBSA, could independently verify this, as well as we used F5 load balancers. So they have their own tool where you can import your configuration, and it'll come back and tell you all the patches and configuration issues with it. It's pretty handy. So now that I've discussed my experiences when vulnerability management, I wanted to provide some suggestions. So if you want to get this started up at your organization or improve your stance on this as a company, here's some things you can look at. So the first recommendation, bring in a consulting firm to perform a security audit based on those top 20 critical security controls. And these security controls include, number one, inventory of authorized and unauthorized devices. So there's your Nexpose discovery scan. Number two, inventory of authorized and unauthorized software. So there's your credential scans that give you that information. And number three, vulnerability management, which is why I'm standing up here. So our second recommendation, stand up a vulnerability scanner compatible with most, if not all, devices in your organization. Simple discovery scan, the first pass there, relatively quick, minimally invasive. It might take a while, but it's going to help you a lot just to understand the assets you have out there. Secondly, run your credential scans that we talked about a minute ago. And based on the size of your organization, you'll want to break these down by IP range or geographical location, organizational unit, or asset type. Next, create device hardening standards. A good way to do this, and here we're back to the Center for Internet Security, CIS. They have the CIS benchmarks. These are super handy, and they provide advice for hardening a device based on its operating system. And those are all included here: Cisco router, switch, firewall, all the operating system, and even multifunction devices, even printers. Here's covered there. I thought that was neat. Some vulnerability scanners you have, Nexpose and Nessus are two examples I'm going to use, can run a specific type of scan against a device and provide a CIS benchmark report, which is very handy when you're trying to put up some documentation for your auditors. I know Nessus has a really cool capability where you can export your router switch config into Nessus, and it'll do an offline scan, come back and tell you everything that's wrong. It's really cool, especially since Nexpose wouldn't do what we needed to do there. No offense to Nexpose. So our next recommendation, hire a professional penetration testing firm. And you want them to simulate attacks on any devices that are external, outside your organization, in that external space. Anything with sensitive data. If you're doing PCI compliance or HIPAA compliance, they're probably going to force you to do this anyway. And finally, anything that's compliance related. So if these recommendations are a little bit too resource intensive, and they can be, especially if you're a small shop, look into software as a service. And these solutions are great because they require minimal infrastructure cost, and it allows a person or an organization to focus on using the application instead of trying to administer, deploy, and maintain it. It's very handy. So our key concept here, if you missed everything else I said, tune in for this one. The key concept is to base an information security program around goals and strategies, not a tool or a set of tools. All the vulnerability sources we went through and the vulnerability scanner, all that is really handy. But no combination of those things can tell you everything you need to know about your environment. So it's very important you base it around goals and strategies. So your approach to vulnerability management has to be comprehensive, has to cover as many areas, as many device types as possible. Next, it's got to be concerted. Have all your teams working together towards this common goal of eradicating vulnerabilities, because that's going to happen. It's really not. Customized. So here's where we get back to our adjusted scoring system. So you can have it customized for your organization. Consistent, the same for all teams, all vulnerabilities, and all circumstances. This was important. We had those vulnerabilities I talked about that we just wanted to write off because it's no big deal, shoulder shrug, quick email from our manager. We don't need to worry about this. But it was important we found out to be consistent and to hold ourselves to that standard of addressing all the vulnerabilities we came across, top 10 at a time. And finally, changeable. So initially, you'll need constant changes to your program. We spent close to 6 months as a team working on our vulnerability management program before we presented it to the first team. And we thought it was great. We loved it. We had celebratory lunches and dinners over it because it was so good. We presented it to the first team and it fell apart. So just keep that in mind. Don't get discouraged when you have to change your program 111 times. So in conclusion, vulnerability management can be a powerful tool for reshaping an information services department, engaging in a cyclical process of identifying vulnerabilities, notifying the persons responsible for addressing them, and tracking the vulnerabilities to complete remediation has the potential to vastly improve an information systems department. Any questions?
All right. Then one thing I was wondering is that you described that you had quite a big network.
Yes.
But with a big network, with a bigger vulnerabilities comes a lot of work, right?
Very much so.
And I guess the IT people has had a lot of things on their plate already. So how do you manage to do that in practice? Because that's what it all looks good and great in paper and all that.
It is great in paper. Yeah,
exactly. But what you remediate and then new vulnerabilities come around. You scan again, and it's a lot of work. So how to do that in practice? Could you describe that, please?
Yes. So that's why we wanted to limit ourselves to 10 per team per month. Because if we came out and wanted you to fix everything, and sometimes we could lump them together. Like if there was your Patch Tuesday and you had 2 patches that were within that Patch Tuesday, you could just tell them, hey, here's all your Patch Tuesday findings. You can go patch those. And by limiting it to 10 per team per month, we could let them take small bites and small chunks and pretend that those other ones didn't exist for 30 days.
But will it ever get better then?
It would get better. It would get better. Teams, usually after we had implemented it for about 6 to 8 months, we found that the teams only had 2 or 3 items per month. It had worked its way down that far and improved their business process at the same time to where it was just easier as an organization to deal with vulnerabilities, even outside of our top 10 process.
How frequently do you run vulnerability scans, and do you get pushback from asset owners who say that's an out-of-date scan? How do you deal with that?
So we run them monthly, on a monthly basis, and it was a rotating schedule, so we didn't vulnerability scan everything on the first Tuesday of every month, for example. And it was broken down by IP range, device type, like I talked about a minute ago. And we usually would have to do a change request, like get it approved by different people. But if the asset owner was like, we fixed it, run another scan, we could just do it right then and there on demand, assuming that we had time to run that scan for them and that it wasn't going to take their system offline, which usually was not the case.
One more, anyone? All right.
Thanks so much, guys. Appreciate it.